Limitations of Newton's laws. The good old Newton's laws. You read about them no matter what profession you practice or what studies you are pursuing. We will zoom in on the fine print and make explicit the implicit, point out hidden assumptions and what-ifs. Point out hidden assumptions. First, a recap of Newton's laws of motion. Newton's first law. An object at rest will remain at rest and an object in motion will remain in motion unless acted on by an unbalanced force. An object at rest will stay at rest and an object in motion will remain in motion. Newton's second law. The acceleration of an object equals the net force acting on the object divided by the mass of the object. Newton's third law, which states that whenever one object exerts a force on a second object, the second object also exerts a force on the first object, equal in magnitude and opposite in direction. Well-known spoilers. 1. Newton's laws of motion are not applicable in a non-inertial, accelerated, frame of reference. 2. Newton's laws are only applicable to point objects. 3. Newton's laws are only applicable to rigid bodies. 4. Newton's laws are most effective when dealing with macroscopic objects moving at speeds much slower than the speed of light. At the atomic and subatomic levels, where quantum mechanics governs behavior, these laws become less reliable. 5. Newton's laws are not compatible with Einstein's theory of relativity. 6. Newton's laws fail to explain how the gravitational attraction arises. This is explained by Einstein's general theory of relativity. Less known spoiler. Force and acceleration do not go in the same direction in metamaterials that uses electrical signals to control both the direction and intensity of energy waves passing through a solid material. We will kick off looking at fine print by taking an excerpt from a well-known educator. I quote. The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. Acceleration takes place in the direction of force applied. F equals ma. Suppose a cat is kicked by its master. The cat will progress in the direction in which it was kicked. Its acceleration depends on the amount of force with which it was kicked. Now a cat is a living being, having volition, or roughly a mind of its own. What if it says, hey, I am no pushover. I stop after the push. The cat will not progress in the direction in which it was kicked. Enough of the cat. Human behavior is continuous with behavior in animals. Many creatures perform acts that are volitional in the sense that these acts are not determined by immediate signals in the environment and are therefore difficult to predict. Some fine print. As pointed out earlier, Newton's laws apply only to point particles and that too not on the small scale of atoms and molecules where we need to use quantum mechanics. Actually, what we said about the cat is not the only exception. Most laws of physics do not apply right away to biological systems. Take a look at special relativity. Albert Einstein's theory of special relativity says that time is an illusion that moves relative to an observer. An observer traveling near the speed of light will experience time, with all its after effects, boredom, aging, etc. Unfortunately, nothing in the prelude to the theory such as Michelson, Morley experiment anything that resembles living beings such as cats, humans. Here is a brief account of the experiment. Scientists at the time of Michelson, Morley experiment hypothesized that there must be some sort of medium in empty space whose oscillations helps light propagate. This medium was called ether. If ether exists everywhere, then Earth must be traveling through ether. As a result, velocity of light relative to Earth will be different for light traveling in the same direction as Earth versus light traveling in the opposite direction. The experiment showed there is no ether, or in other words the speed of light is constant. Time travel, grandfather paradox etc. implied by special theory of relativity, wrongly applied, Einstein never stated them, arise from faulty generalization that is a conclusion drawn without the backbone of experiment on humans. Experiments on subatomic particles don't count. Here is a brief account of time travel. Time travel is the hypothetical activity of traveling into the past or future. Time travel is a concept in philosophy and fiction, particularly science fiction. In fiction, Time travel is typically achieved through the use of a device known as a time machine. Here is a brief account of grandfather paradox. It occurs when a time traveler creates a self-contradicting scenario where effect precedes cause. If you kill your grandfather before he has kids, one of your parents is never born. Consequently, you are never born. But if you're never born, then you wouldn't exist to go back and kill your grandfather in the first place, would you? Paradox. Please share and subscribe to Interesting Channel.